Welcome everyone to my new lecture. Now we are going to my new tutorial. Now I'm gonna show you basic principle working of diode. So let me just go here in my schematic capture in Proteus. Just wait a second. It kind of takes a while because I am recording my desktop, so it isn't as fast as it should be. Okay, here it is. Now let's go to our library, and here in the category you have a subcategory called diodes, and here you have various type of diodes. There are rectifiers, there are generic diodes, there are bridge rectifier. As you can see, there are a lot of types of diodes. There are switching diodes, and so on and so on. But in this tutorial, I'm just gonna show you how a basic diode works. What is the basic principle working of a diode? So I'm just gonna type here diode, and I'm just gonna take this one. And okay, now I'll take one battery. Okay, and maybe a resistor. It's always good to have a resistor in a circuit with a diode. So when I have battery here and I have a diode here, maybe put a resistor like so. Now when I connect these three parts, when I connect these components, then I'm gonna have a closed circuit. Now when I simulate the animation option, okay, so quick. Now you will see that the current is gonna flow from the plus to the minus, from plus to the minus sign of the battery. So you would say, okay, what is cool about that? Well, nothing spectacular here, but when I change the polarity of when I change the sides of the battery, so just wait a second. Now when I connect it like this, okay, when I simulate now, you will see that there is no current flow through this circuit. So diode acts like a switch, or it can be used as a rectifier, or I don't know, a voltage regulator, voltage dropper, and so on and so on. It isn't an active electronic component. When I say active component, I mean that you can't have an amplifications with diodes. So basically it's a passive component, but we use it as an electronic component. Okay, now so when you so let's talk about that. So here this side, where this is one line at the end of this triangle, this side is called the cathode, and this side here is called an anode. When the current goes, I mean the conventional current, when the current goes in the anode and goes out of the cathode, then the diode will conduct. But if you put current on the cathode side, when the current goes through the cathode side and goes out of the anode, then you will have an open circuit, and then the circuit won't conduct any current. So when we have when this anode is on the positive and this cathode is on the negative side of on the positive side, when the anode here to my right is on the positive and the cathode here is on the negative side, power voltage source, then it is called forward biased mode. When it's opposite, when the cathode is on the positive side and the anode is on the negative, we call it reversed bias mode. Okay, but there in every diode there is a voltage drop. I'm just gonna undo some changes. Let me bring the components back. Okay, uh, so when I say there is a voltage droppage, that you for every diode you need to for various types of diode you have to supply with some minimal voltage. For example, in a silicon diode you need approximately 0.6 voltage to 1.7. In germanium diodes you need 0.2 voltage. In Schottky diodes you need 0.4. I mean, when I go to the library here, you go here to the diodes, you can see the specifications of the diode. So this, for example, this 800 volts. So I put here we have a device called a diode. This is the type of a diode, 10A06. Here it says that this is a silicon diode. This 800 volts is a peak inverse voltage. So that's the biggest amount of voltage that can be reversed by. So if you put 800 voltage, more than 800 voltage in reversed bias mode, then the diode will explode. This 10 amperes is the maximum forward current. That's the current that goes from the anode to the cathode. And these three, I think this is the 3 microseconds. That's how long it takes to diode to activate itself. So here example we have 10A01. You can see that the peak inverse voltage is 50 volts, and if you apply more than 50 volts on this battery, it will burn itself. Here and there are a lot of types of this diode, but it doesn't say for now what is the voltage droppage here. But okay, it's not that necessary. That we can always measure what is the maximum voltage drop. So for example, on this diode, if you want to measure the voltage drop, we go here to the DC voltmeter, put in parallel here. Okay, so now when I apply current, as you can see, there is 0.69 volts on this diode. So we need approximately 0.69 volts to activate this diode, or 0.7, I don't know. But yeah, that's it. And let's measure the current flow here. Okay. When we want to measure the current, we want to put the DC ammeter in series. Oh, sorry. DC ammeter. Okay, the diode, the current that goes through the diode is very small, so we cannot measure with this ammeter what is the current through this diode. But as we can see, we see that there is a current going through, and this resistor is very high, and the current is very small. But as you can see, the diode has a power consumption, and you have to apply a voltage through it. Okay, so that's kind of it for now. But no, I just want to show you that you can also use sinusoidal voltage sources. When we just a second, I don't need this anymore. Don't need this. For example, let me just remove this resistor. I'm gonna put a lamp here. I'm gonna put a. I mean, you always have to put some kind of resistors, you know, with the diode. But this is a program, so it's not gonna happen anything rapid when I don't put a resistor here. So I'm gonna change the values here. Let's say that the amplitude will be about 12 volts and the frequency, let's say 1 hertz. So when I connect, as you can see, the current goes only in one direction. And then when this generator goes in the other direction, then the diode will block the current flow, and as you can see, the current will always go in only one direction. So let me put an oscilloscope to measure to see the voltage here. And okay, now when I run the program, so okay, I need to cancel channel, and just a second. Okay, now just a moment. I just need to adjust the current here. Okay, no, I had to go here. Sorry. Just wait a second. I just need to adjust. Current here, going here. Okay. All right. So. And now, as you can see, just let me go put it here on the 0. 1 second. It's kind of hard here to. Now, as you can see, the generator goes like this, a little bit in a sinusoidal way. But as you can see, when this side is negative, this side will be positive. If this side is positive, this side will also be positive. So the lamp is always in a positive mode, but not always, because there is a reversed bias mode. Okay, no, just so this is how it changes. This is the green is a generator, and that's how the voltage across this lamp and the generator changes with the diode. So it's not adjusted as well it should be. Okay, that's it. I think I showed you how the principle working of a diode. It goes through one side, or from the anode to the cathode, but it blocks from the other side. So it's kind of I don't like to work with oscilloscope in Proteus. It's kind of hard. It's always better to do it in spy simulation and in real life with oscilloscope, but it's hard, a little bit harder in the program. So that's it for now, and see you in my next tutorial where I'm gonna show you LEDs. Goodbye.